Okay, this is a overview of the Mars lander assignment. So if you haven't already watched the video on sound and graphics, I suggest you watch that first. So in this program, you're going to be making heavy use of the StdDraw.java class and the StdAudio.java class. And your goal here is to create a game called Mars Lander where you navigate your little spaceship in for a safe landing on the little red pad. So let me go ahead and I'll just show you uh, my, myself playing the game. It's the main program is going to be in Mars Lander, the only program actually, and it reads in from standard input a level file, and this controls various things about the game. So let's just run level 0. And there's my ship. As you notice, if I don't do anything, it just accelerates downward, and then once it hits the ground, it crashes. So you're not allowed to land on, you must land on the pad. Okay. But you can also control your ship by pressing the W, A, and D keys. And what I'm trying to do is come into a soft landing on the pad.
Yay!
Hooray! So that's when it goes well. You can come into soft landing outside the red pad, but that also results in the lander crashing. So here I come into a soft landing. Oh. Alright, you must land within the bounds of the red box. There's nothing to prevent you from going off the screen, so I could thrust up, and my ship will kind of disappear for a little bit. Kind of still see it, and then it eventually, the force of gravity will draw it back down. Same goes for left and right. You can go off the screen, but then if I'm quick enough, I might be able to make my way back. Nope, nope. I guess I hit the ground, I just couldn't see it. This level file, if we look at the level file, controls various things about the game. The first number here, 1500, specifies we were going to have 1000 pixel width by 500 pixels high. Mars sky is the background image that you can draw in the center of this window. Then we've got various sprites for drawing the ship, like the normal ship. The ship when its bottom thruster is actuated, when its left thruster is on, right thruster, when it's successfully landed, and when it's crashed. Alright, then we have 20 and 50. And what the heck is 20 and 50? Well, I don't even remember, but you can check out the comments at the end of the file actually tell you what the various numbers are. So after the ships, we have the horizontal distance. So this measures how many pixels it is from the center of the ship to the edge of the thrusters, as well as the vertical distance from the center of the ship to the bottom of the edge of the thrusters. So you're going to have to represent your ship as like this box, and that box needs to be inside the bounds of that landing pad. And you also need to know when use the second number there, the 50, to determine when the bottom of your ship has either hit the ground or successfully landed on the pad. You've got a starting X and a Y position for the ship. That's the 500, 400. You have a starting amount of fuel, and if you notice while I was playing the game, in the upper left there was a fuel counter. Once that fuel counter, every time I fire one of my thrusters, it takes 1 unit of fuel, and once I'm out of fuel, then I'm just at the mercy of gravity. We've got 3 different wave files, thrust.wave, yay.wave, and explosion.wave. The first is the sound that happens when you actuate any of the thrusters. This is the sort of success sound when you've won the game, and then this is the explosion sound when you've crashed. The gravity term is what you add to your velocity at every time step of the game. And it's a very simple model of gravity. As if you don't do anything, your gravity term is going to get this much bigger at every time step, and therefore you're going to start going down faster and faster. And so the physics are quite simple, is you just add the velocity term to your Y position, and your lander will start going down towards the ground faster and faster. 2.0 is the maximum survivable velocity. This is how fast you're allowed to be going when you hit that landing pad in either the X and Y, either in the X direction or in the Y direction. If either your velocities is faster than that, then it's going to be a crash. 0.5 is how much your thrusters counteract gravity if it's the upward thruster, or how much they make you go left or right if it's the left or the right thruster. And then finally we've got this center X position of your landing pad, and then how far it is from that center position to each of the edges of the landing pad. So these are all the configuration options, and your first task in this assignment is going to be to read all this information in, parse it. You must read it from standard input, parse it into appropriately named variables, and then you'll use those variable names inside your program. The advantage is, by doing it this way, we can have different level files. So I just showed you level 0, but level 1 is a slightly different file. It has a lot of the same things, like it has the same ships and sounds, but if we run level 0 or level 1, you can see my ship started at a little more difficult position. And as we go up, we can see what files we have. We have all the way up to level 5, and level 5 is actually quite hard. I only have 60 units of fuel, so in those 60 units I've got to get all the way over here and then land on this really tiny little pad. It can be done, but it may prove slightly difficult to do. Let's give it a try. Oh, I'm coming in hot. Look out. Ah! Oh, yeah. That was a good effort. That level's pretty hard. You can also download, you'll get these levels 0 through 5 in the normal zip file. There's also an expansion pack, and if you run the expansion pack, this has a whole different set of images and sounds. Oh, I forgot my less than sign there. And I can try and land on the pad over to the right side. I think I'm going to crash. And this is the same program, it's just different input to the same program. Let's see if there's anything more. You can read more about exactly how to do the gravity and thrusting, so please do read the assignment webpage thoroughly before you start the assignment. And here's a little bit about the setup. You're going to set the canvas size to the width and height specified by the file, so for example 1000 by 500 pixels. And then for simplicity, we're also going to use a coordinate system that's the same. So you'll refer to where to draw things and so on in your game with pixel coordinates. And so in order to do that, remember StdDraw defaults to having a coordinate system in the unit box. So you want to call set X scale for 0 through the width, and set Y scale. So there's a typo on the web page. I'll have to fix that. There should be set Y scale 0 to the height. If you're wondering how to sort of do animation and respond to keyboard input, here's a good example, boxcar.java. So let me open that up in Eclipse. This program is, well, it's the world's simplest car simulator. And so I'm hitting the, what am I hitting? A, D, S, and W, S, A, and D. And I can drive my little car around with sort of simulated velocity. And I go around, and it makes an explosion sound whenever I hit one of the walls. And so that's that. So you can have a look at this. This code shows you how to do drawing, shows you how to play sounds, it shows you how to detect keyboard input and check which characters are actually hit. So a lot of these sort of things are very similar to what you're going to need to do in Mars Lander. And obviously there is room, if you get done with Mars Lander, there's lots of new things you could do. For example, you could make a new expansion pack with new graphics and sound. You could also make a more sophisticated game, like I made a version that loads a more complicated configuration file. And now I've got obstacles. So these gray boxes are things that if I hit, I crash. So to actually land on this red pad, I'd have to negotiate my thing around this complicated cave.